Hi, good day to you. Today, basically, I'm going to talk about macronutrients, the carbohydrates. In this recorded lecture, I'll basically look through a few learning objectives. First, I will try to explain to you what are different types of the carbohydrates based on the chemical structures. So we need to know what are monosaccharides, disaccharides, and polysaccharides. Okay, which are commonly found in our diet, okay, and it's part of our nutrition. And basically, we also explore what are the major food sources of all these monosaccharides and polysaccharides. Next, I would like to talk about the carbohydrates digestion and absorption in human, and we will also talk about the implications of added sugars to our health. And finally, I will summarize the health benefits and recommendation of starches and fibers based on the nutrition guideline. There is always a misconception that basically that we try to curb carbohydrates in our diet because we feel that or we think that carbohydrates is basically contributing to obesity. Okay, carbohydrates is fattening, and therefore we must avoid carbohydrate if we want to manage our weight. But this is a very serious misconception that I'm trying to correct today. Okay. What exactly are carbohydrates? Okay. Now, basically, carbohydrates are basically a type of nutrients that our body needs, and basically they're present universally in a lot of our food, right? They're present in whole grains, they're present in vegetables, they're present in meat products, milk, legumes. Okay, now definitely we have to understand that there are different types of carbohydrates, and the carbohydrates in refined sugar, right, is need not or may not be equivalent to the carbohydrates in whole food like whole grains, vegetables, milk, and legumes. So we cannot blanket like carbohydrates is basically fattening or carbohydrates adds to health problem, etc. Now, if you look at the different types of carbohydrates, basically, we in our diet, basically carbohydrates are actually classified in two main types. First, we have the sugars. Okay, now the sugars is a very bad term nowadays because a lot of health authorities all over the world has actually attributes obesity and its metabolic health complications to the consumption or the intakes of sugars. Okay, in fact, humans like us have been taking too much sugar into our system, and therefore the amount of sugar that we take actually really compromised our health status. Now, sugar itself basically is a form of carbohydrates, and sugars are usually chemically structured into the monosaccharides and the disaccharides. Another branch of carbohydrates that's in our diet belongs to this branch of diet because it's starch. Okay, the starch that's commonly found in our whole grains and our rice, etc. Traditionally, we get our carbohydrates from grains, like in Asians we get our rice. In the Western countries, basically more wheat or millet or rye or barley or even oats are consumed in the normal diet. These are the normal, I think it's the traditional sources of carbohydrate, okay, whether it's in the Asian or the Western diet, the grains. Now we also can get the carbohydrates from different food sources, well, like the legumes, in the beans, the peas, the lentils. Right, processed carbohydrate includes like bread, pasta, and noodles. Okay, we can also get carbohydrates from those healthy fruits and vegetables, and even in milk. Like I previously said, carbohydrates is a very, very important macronutrient. Okay, much of the negative publicity of carbohydrate intakes. Carbohydrate is one of the most important energy-using macronutrients. Okay, now apart from carbohydrates, the proteins and the fats are also energy-using. That means they actually provide energy to our body. But carbohydrates is actually the most important one. Okay, it's the important part of a healthy and a well-balanced diet. So the key point is not whether you should be eating carbohydrate. The key point is that how much carbohydrate should you eat, or what's the right amount of carbohydrate should you actually incorporate in your diet? Now, as we discussed in our previous slide, carbohydrates are abundant in a wide variety of foods, and there are many different types of carbohydrates. Remember, our first learning objective is basically to look at carbohydrate, right? Look at the chemical structures of each type of carbohydrates. Chemical structure-wise, we broadly divide the carbohydrates into the monosaccharides, the disaccharides, and the polysaccharides. What are monosaccharides exactly? The monosaccharides are the simplest sugar. So basically, it basically are sugars that contains one sugar unit, right? So disaccharides, the word di implies is actually two single sugar unit, right, combined together. And polysaccharides are those with multiple, sugar units, like linked together, and they form a chain of single sugars. So in general, basically, right, the monosaccharides and disaccharides are, from the nutrition point of view, collectively the monosaccharides and the disaccharides are termed as sugars, while else the polysaccharides, right, the more complex change of sugar units, right, are actually termed as, complex carbohydrate, okay, and the complex carbohydrate are usually made up of starches and fibers. Okay, let's go in details of what are the different types of carbohydrates. Now, carbohydrate is the most important source of energy using macronutrients, and essentially chemically, right, they're made up of three elements. Okay, carbohydrates basically is made up of carbon, oxygen, and hydrogen, right? And these carbon, oxygen, and hydrogen atoms basically are bonded together to form our monosaccharides, and basically multiples of monosaccharides, be it the disaccharides and the polysaccharides. So let me recap to you the carbohydrates family. We have the monosaccharides that make up of single sugar units, right? Mono means one, saccharides means sugar. And some typical examples or the three commonest monosaccharides that found in the diets are glucose, fructose, and galactose, right? And generally they have this general chemical formula C6H12O6. Okay, the chemical formula C6H12O6 just basically tell you that in a molecule of a monosaccharide, there are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Now, the next class of carbohydrate, we term them the disaccharides, right? Basically, the disaccharides contains 2 sugar units bonded together. As the name di implies, it means 2. Common disaccharides present in our diet include sucrose, lactose, and maltose. And lastly, we have the polysaccharides, or we term them the complex carbohydrate. Okay, this is a very big class because anything that is more than 3 sugar units bonded together is termed as a polysaccharides. Poly has the same meaning of many. Examples of polysaccharides, common examples of polysaccharides found in our diet includes glycogen, starch, and fibers. So let's talk more about the monosaccharides and the disaccharides. Remember, the common monosaccharides found in the diet are the glucose, fructose, and galactose. Together, they form our 3 common disaccharides. If you have 2 units of the glucose molecules linked together, what you have is actually the maltose. Okay, so maltose is basically 2 units of glucose, right, monosaccharides linked together. Similarly, when we have a glucose and a fructose linked together, we have sucrose. And basically, lactose is a disaccharide made up of a sugar and a galactose unit chemically combined together. Let's talk in details about what are the different common monosaccharides. For example, glucose. Glucose is also called the blood sugar because basically glucose is found abundant, or how do I say, is regulated in our blood sugar. It's the simplest form of energy using sugars that we have in our body. Okay, it serves as a very important source of energy for all body activities. Right now, basically glucose can be found in all disaccharides and polysaccharides. What about fructose? It's also a monosaccharide, right? Fructose is found predominantly in fruits, so it's also known as the fruit sugar. Right? Abundance in fruits, honey and juice. Other sources can be soft drinks, ready-to-eat cereals, etc. So processed food also contains high amount of fructose. Galactose is naturally found in foods in small amount comparatively to glucose and fructose. Galactose are basically present in much smaller amount in nature or in food. Okay, right? It makes up the part of a disaccharide lactose, right? And basically, where do we get our galactose in our diet? We get them mainly from lactose-containing products such as milk. Next, we talk about the disaccharides. Okay, for maltose, remember, maltose is basically a disaccharide that just make up of 2 units of glucose chemically bound together. Sometimes we call them, in the industry, call them the malt sugar. It's produced whenever starch breaks down during digestion. So when starch is broken down during digestion, it will form the maltose, okay, before it actually undergo further digestions to give you the glucose. Right? It also formed during fermentation, right, process. When carbohydrates are fermented, right, they yield maltose and sometimes and alcohol. Now next, when we talk about sucrose and other disaccharides, remember sucrose is actually made up of a molecule of glucose and a molecule of fructose chemically combined together. Now sucrose is actually the common table sugar that we used, right, in our cooking and our baking, right? We call them, it is commonly called the table sugar, beet sugar, or the cane sugar, right? And sucrose basically occurs in many fruits and vegetables and grains. Lastly, let's talk about lactose. It's also known as the milk sugar because this is the predominant sugar found in milk. Okay, and lactose is a disaccharide that make up of a unit of glucose and a unit of galactose chemically combined together. Let's talk about polysaccharides. Okay, like I said before, polysaccharides contains 3 or more units of sugar chemically combined together to form a chain. It can be a straight chain, it can be a branch chain, but overall, polysaccharides are definitely more complex than the disaccharides and the monosaccharides. They usually contains more glucose unit and a few other monosaccharides string together. The 3 important types of polysaccharides in nutrition are the glycogen, starches, and fibers. Let's talk about one of the important polysaccharides, glycogen. Glycogen is an animal polysaccharide, okay? So basically, glycogen can only find in animal, right? You cannot find glycogen in plant, okay? Please take note of that. So it's an animal polysaccharide, and basically, these polysaccharides, glycogen is just made out of glucose. So we have many glucose monosaccharides unit chemically bond together to give you glycogen. Now, where is glycogen made? It is made and stored by the liver. That's why it is only present in animal. Do you see a liver in plant? Right? It also made and stored in the muscle tissues, right, of the mammals, right? And usually glycogen is the storage form of glucose for future use. So if we have excess glucose in our body will actually use this excess glucose to make, right, or I would say the liver will use this excess glucose to make glycogen and store it in the liver and the muscle tissue. And when we need, or when our glucose level in our body is low, right, this glycogen will be metabolized to release this sugar. So this glucose will be made available when liver or muscle cell receive a hormonal message to release energy. Right. Now, please remember, although glycogen is also present in food, in meat product, usually glycogen is not considered or counted as one of the complex carbohydrate in foods, because at the end of the day, right, our digestive system have no ability to actually metabolize glycogen into glucose for absorption. Now, a very important difference and things that we need is, okay, our human body store glucose as glycogen, like I previously discussed, in the previous slide. when we have excess glucose in our body, our liver will actually actively convert the excess glucose into glycogen. And when we need the energy, the glycogen will be converted back to glucose. Now, plant have the same mechanism. However, plant do not have a liver. So plant do not store glucose as glycogen. Plant store glucose as starches. Okay, so that's the difference. Okay, right? Whether it's a human body or plant cells or plant, they use glucose as the energy providing unit. However, the difference between them is that the human body store glucose as glycogen, while the plant store glucose as starch. Now let's talk about the dietary fibers. Okay, dietary fibers basically came predominantly from the plants. Okay, they are the structural parts of the plants. Okay, and because they are structural components of the plant, is always present in all plants derived food, whether it's vegetables, fruits, whole grains, or legumes, right? And remember, they are a type of polysaccharides. Okay, and sometimes in nutrition we call them the non-starch polysaccharides. Remember, there are basically three forms of polysaccharides: the glycogen, the starch, and now what we have here are the fibers. Fibers are very unique. Okay, I don't know whether we should term them nutrients or not, but dietary fibers is actually, according to nutrition and dietitian, is a very, very important nutrients. But dietary fibers as a nutrients, right, is a very special one because dietary fibers are not digestible by our human digestive system. That means you cannot break down dietary fibers in our gut, and therefore there's no way that we can absorb any of the sugar units, right, in the dietary fibers. So the dietary fibers actually pass through the body. That means they pass through the entire human digestive system. It does not contribute any monosaccharide, doesn't contribute any glucose or whatever sugars, etc. And therefore it doesn't contribute to any energy. While we are here at this topic of dietary fibers, maybe I should talk about how dietary fibers are so important to our health or to our body, even though, right, it doesn't contribute any sugar, any energy, because it's basically indigestible, in our human gut. As I have mentioned many times, the dietary fibers in our diet are basically non-digestible, right? Categories wise, there are two types. We have the soluble dietary fibers, we have the non-soluble dietary fibers. And essentially, both fibers are required in our diet. Now, according to the nutritionist and the dietitian, okay, for a healthy human body, the recommended daily allowance for dietary fibers is basically 14 gram per 1000 kilocal. So if for a normal 60 kg person who requires around 2,000 kilocal of daily energy, basically our recommended daily we should be eating around 28 grams of dietary fibers. Now this table basically shows you the difference between the soluble and the insoluble fibers. Okay, soluble fibers basically, as the name implies, it can dissolve in water, and when it dissolves in water, it forms a very viscous gel, right? And because of solubility being soluble in water, they are easily digested by bacteria in our large intestine, right? And the terms we call that is called fermentable, right? Where can we find soluble fibers in our diet? We can find them in oats, legumes, barley, and fruits. Okay. Now, a lot of clinical studies have actually suggested that soluble fibers basically can protect us against heart disease. And how does it do that? It's lowering our blood cholesterol, or it can also protect us against diabetes by lowering blood glucose. How about the insoluble fibers? As the name implies again, the insoluble fibers do not dissolve in water. They cannot dissolve in water. It's insoluble. And because of that, it doesn't form any gel, right? Basically, what you see is a suspension, right? You have the insoluble fiber suspending in the water, right? And because of the insolubility, they're less likely to be acted upon by bacteria, so they are less readily fermentable, right, in our human gut. And we found these insoluble fibers mainly in whole grains, vegetables, and most fruit. Now, what are the important functions of insoluble fiber in our diet is that it promotes bowel movement and alleviates constipation, right? It provides the bulk and the feelings of fullness, and basically insoluble fibers can help us in a way in managing our weight. So on this slide, basically I summarized the various health benefits of dietary fibers, right? It it helps to lower blood cholesterol, right, in one way, and therefore prevents heart diseases. It reduces the amount of blood sugar or control it very well, and therefore prevent and control diabetes because of its unique functions of promoting or preventing constipation, promoting bowel movement. Basically, it actually protects or promote the gastrointestinal health, right? And keeping a healthy gut and a gut microbiota means the bacteria inside the gut actually prevents colon cancer, and directly and indirectly, because of our healthy guts, it can actually help better manage our weight. These slides basically look at the reason why we should choose whole grain versus whole wheat, right? Or polished grains or refined grains. Okay. Now, when we talk about whole grains, we're talking about the whole grain as in the whole seed, and the whole seed contains both the germ, the endosperm, and the brunt. Okay. Effectively, we look at this diagram, you can see that actually predominant amount of fibers, most of the fibers are found in the brunt. Okay, the endosperm of a grain, which is the part that gives you the white thing, or it is mostly starch. So when we eat polished grain or polished wheat, we are actually taking only the endosperm, right? They remove the germs, they remove the brunt from the wheat grains, leaving only the endosperm, right, during the polishing process or refining process. So when you look at flour being very white, etc., basically they are just starch from the endosperm, as the germs and the brunt has been removed. So if we're taking wholemeal flour, for example, what they did is basically remove the germ, and they actually grind down the endosperm and the brunt to give you the wholemeal flour. And because brunt is still present in the wholemeal flour, the dietary fibers that is originally in the grains or whole grains are conserved, and you basically are eating those fibers in the whole grain. Next, I understand that we have been talking about this previously when we talk about carbohydrate is the most important energy during macronutrients. Let me now drill into the details about the functions of carbohydrates in our body. Apart from being the main source of body fuel, which means that it's the primary source of energy in our body, right? Basically, carbohydrates is basically just provides energy in a sense. Okay, right? Whether is it converted to glycogen or whether is it energy for the brain, basically it's the energy for every parts of our body. Okay, carbohydrate is also very important as it actually, forming the bulk in our diet such that, our bowel can move effectively, preventing constipation, etc. And that is the part whereby, the dietary fibers is actually doing most of the job. Okay, adequate carbohydrate spares the protein so that the proteins are used for body growth and repair. So, okay, remember I told you that, apart from carbohydrates, proteins and fats are also energy giving. That means we can metabolize proteins and fats to give us energy. However, right, proteins have other important functions other than energy providing. Proteins are there to actually provide the amino acids used for growth and repair of our body. So if we do not have sufficient carbohydrate intake, right, instead of actually getting energy from the carbohydrate, we'll be getting energy from proteins. And if we get energy from proteins, less proteins are available for growth and repair of our body, and this is not what that we want. Next, we move on to the digestion and the absorptions of carbohydrates. Before we actually look at the digestion and absorption of carbohydrates in our human gut, let's revise to what is exactly our human digestive system. Basically, our human digestive system starts at our mouth, right? Okay, we begin our digestion process in the mouth. Okay, we'll talk about it. Okay, in subsequent slides. After which, the food is usually passed on, right? Which is channeled down to the stomach via the esophagus. Okay, so the stomach is the is the third port of call, mean down the esophagus into the stomach. Then the stomach will go to our small intestine, right? The small intestine is the part whereby most of the digestion and the absorption will take place. Then the food that's still remain, the food will actually pass right into the large intestine, and before it is the feces is formed and collected in the rectum and pass out of the body via the anus. So basically, our digestive system is made up of the mouth, esophagus, stomach, small intestine, large intestine, right, rectum, and finally the anus. Digestion of carbohydrate begins in the mouth. Okay, once we bite our food, we will start chewing it, right? The amylase in our saliva, or we call it salivary amylase, right, will begins to break down the starch in our food. Okay, right, it begins to break down the starch, and the starch was broken down into smaller polysaccharides. Okay, right. Subsequently, the polysaccharides will break down into dextrins and eventually to the maltose, which is the disaccharides comprising of 2 glucose units. Now, the longer the starch remains in the mouth, that means the longer you chew or the food remains in the mouth, the more digestive action can take place by the amylase enzyme. Next, remember the food will actually channel down to the esophagus and reach the stomach. So in the stomach, mixing and churning will occur, right? The starch and the simple sugar are mixed, okay, in the stomach, and because of the acidic pH in the stomach, or the stomach secretes a lot of hydrochloric acid, and therefore lowers make the pH of the stomach content, or I should say, making the stomach content highly acidic. Starch amylase basically works on a slightly higher pH, or we say alkaline pH, and therefore starch, okay, in the stomach, the amylase in the stomach will be deactivated. Okay, now the stomach acid or the hydrochloric acid breaks down the starch further. Okay, because there is no stomach amylase, right? Therefore, starch digestion usually does not occur in the stomach, except that the hydrochloric acid in the stomach do further break down the starch, okay, chemically, right? Now, in the stomach, fibers basically will actually cause the whole stomach content to be very viscous. That means very thick, right? And because of that, right, our food stays longer in our stomach before it is actually channeled into the next port of call, the small intestine. So after the stomach, okay, the food will actually reach the small intestine. In the small intestine, okay, basically pancreatic amylase will be secreted to the food materials in the small intestine, and the pancreatic amylase will continue the digestion of large polysaccharides into maltose, into glucose. Okay. It is also at the small intestine that all the small monosaccharides, the single sugar unit molecules, will be absorbed, right? Right, the starch, everything, the disaccharides, the polysaccharides will be digested into the monosaccharides. Now the monosaccharides are small enough, right, to diffuse, right, through the cells, the epithelial cells of the small intestine into the blood vessels, right? Okay, that's how absorption takes place. So if you look at the chemistry of digestion, basically, all the digestive process are catalyzed by the amylase, the enzyme. okay, like maltose is catalyzed by the enzyme maltase to get you the glucose. The sucrose itself basically with the enzyme sucrase to give you your fructose and your glucose, and the lactose is the lactase to give you your galactose and glucose. Like I mentioned earlier, that when monosaccharides are formed after digesting all the polysaccharides and disaccharides in the small intestine, these monosaccharides become small enough to be absorbed in the intestinal cells, enter into the bloodstream. The blood will actually bring all these monosaccharides to the liver. So in the liver, the fructose and the galactose are converted into the glucose. Remember, our body only can metabolize glucose. That means we can only use glucose to actually get energy. So our liver have enzymes to actually convert all these fructose and galactose into glucose. Now, depending on what is the glucose status in our body at that time, okay, now the glucose can be used for energy, right? But if there's excess glucose, what happens? Our liver have the enzymes to convert this excess glucose into glycogen, and this glycogen is stored either in the liver, they are stored in both the liver and the muscles. Next, we look about the large intestine. Okay, now most of the absorptions and the digestion would have finished in the small intestine, and by the time the food material, or I don't know whether I should call them the food material anymore, reaches the large intestine, right? Basically, it's just predominantly fibers and waste materials. So the fiber will pass intact through the digestive tract to the large intestine. Now, in the large intestine, there's a lot of bacteria, and remember I said, the soluble fibers can be fermented, can be acted upon by the bacteria enzymes, right? And what are the byproducts of all this fermentation? The gas and the short chain fatty acid. Now, remember the insoluble fibers also have the ability to hold water, regulates bowel activity, and bind substances such as bile, cholesterol, and some minerals, so that we can actually expel them out of the body. We just learned that glucose is a very important nutrient for our human body, as it is actually the one and main energy source that could be used in our body. But how do our body actually regulate the amount of glucose in our body? Okay, we may have eaten a lot of food that contains carbohydrates, and these carbohydrates will nevertheless metabolize in our body into glucose. But how do our body actually control the amount of this glucose in our body? This is what we're going to learn in this session. In our human body, glucose regulation basically is controlled by four important keywords over here. So basically, the four important keywords are the insulin, the glucagon, glycogen, and the amphiphylline. Okay, each of them basically, work together, okay, to actually regulate the amount of glucose in our blood. As you know, our blood basically carries the glucose to all parts of the body, and basically the amount of glucose in the blood basically is regulated at a very, very controlled levels. That is actually the process of homeostasis. Now let's talk about these four key important components that are important in blood glucose regulation. The first one on the slide here is actually insulin. Now, what is actually insulin? Insulin is a hormone that transports glucose from blood into cells to be used for energy, right? So basically, insulin controls, okay, the transfer or the transportation of glucose, okay, from the blood into the cells. Okay, so basically it controls the amount of glucose going into the cells, and after the glucose actually went into the cell, this glucose will be used by the cells mechanism to actually derive energy, okay, chemical energy, which sometimes is ATP. So this process of transport or transferring glucose from the blood into our living cells basically removed or somehow decreased the concentration of concentration of glucose in the blood, and therefore helps to lower our blood glucose level. Next, I'll talk about glucagon. Okay, glucagon is another hormone, right, that actually control or elicits the release of glucose from storage in response to low blood glucose level. So what does it do? Right, basically it's a hormone that actually convert, okay, or initiate conversion of glycogen in the liver or under the skin or in the muscle tissues into glucose. Now, when does this hormone act? This hormone acts when our body is experiencing low blood glucose level. So what happens is this hormone will start, asking the liver and the muscle cells to actually start converting the glycogen stored in it into glucose, and this glucose will go into the bloodstream and thereby increases the blood glucose concentration. So next, let's talk about glycogen. Okay, as I said previously in my previous slides, glycogen is basically the storage form of glucose in our human body. Most of the glycogen is actually kept in the liver or the muscles, and when we need it, when our blood glucose level is very low, the hormone glucagon will actually initiate this conversion of glycogen into glucose. And this glucose will enter the bloodstream and increase the blood glucose level. Amphiphylline, I don't know whether I should pronounce it correctly. I can never actually pronounce this word very well. It's actually a third hormone. This third hormone basically releases glucose from the liver in a very stressful situation. So when you are actually when you are under physical conditions or physical activities, etc., this hormone will actually convert glycogen to glucose. Okay, and this only acts in the liver. So from the previous slide, we understand that the few hormones that I mentioned, okay, basically acts to actually regulate or balance the amount of glucose in our blood. Okay, and we need to do that because high blood glucose concentration will lead to certain physiological issues, or low blood glucose concentration will also lead to certain undesirable physiological effects. So the balancing of or the regulations of blood glucose is actually acted upon by these few hormones working together. So let's use this diagram to basically understand how do these few hormones actually work together to regulate the blood glucose content. Now, let's start with the top right-hand corner of this diagram where there's label number 1. Okay, after a meal, blood glucose levels increased. Okay, what happened is, when we eat, the food goes into our digestive system, and the digestive process actually converts or digests the carbohydrates into simple sugars like glucose, and this glucose will enter into our bloodstreams. All this glucose will be absorbed in the small intestine and enters into our bloodstream. Right. So because of the significant amount of glucose entering the bloodstream, the blood glucose level actually increases. And this increase in blood glucose level or concentration basically stimulates the release of insulin, which is the hormone. Okay, this insulin is actually manufactured by the pancreas and is secreted by the pancreas into our bloodstream. Now, what does this hormone insulin do? Remember, I told you previously. Let's move on to point number 2 in the diagram. The insulin stimulates the uptake of glucose from the blood into insulin-sensitive tissue cells. Okay, so basically, remember, insulin is a hormone that actually facilitates the transport of glucose from the blood to the cells, to the tissues, the cells in the tissues, right, be it muscle cells or adipose or fat cells. Now, the transport of glucose from the blood to the cells itself basically acts to lower the blood glucose concentration. Now, in the liver, insulin also do a secondary process. It actually promotes the formation of glycogen. It actually convert the excess glucose, right, Since the blood glucose concentration is high, so the insulin in the liver will actually start a process whereby this excess glucose will be converted into the storage form, the glycogen, and this glycogen will be stored in the liver. Now, this is when the blood glucose concentration is actually high, especially after a meal or after a very, very high sugar snack. Okay. Now, what happens when there's excessive conversion or excessive usage of glucose in our body? Like, for example, under high physical activities, your body experiencing low blood glucose. Now, when our body is experiencing low blood glucose, basically this low blood glucose situation will promote a production or the release of another hormone. We call it the glucagon. And it's often also from the pancreas. Okay, right? And this glucagon, in turn, basically facilitates or stimulates the breakdown or conversion of glycogen back to the glucose in the liver. Okay, and this glucose, right, from the stored glycogen will be released into the bloodstream and thereby increases the blood glucose concentration. So this is how these two basically important enzymes actually helps to regulate the amount of glucose or the concentration of glucose in the blood. This diagram here shows exactly the same protocol that our body went through in regulating the blood glucose concentration, just that it's actually maybe it's actually less of the organ diagram, but more on the graphics. So you can actually use this to understand how does our body uses the two very important hormones to actually regulate the blood glucose. In the previous few slides, we understand how do our body, our human bodies actually regulate blood glucose concentrations, where glucose is either readily available or is on the low side. Now, what happens over a period of time whereby the carbohydrate intake is inadequate or insufficient to meet the glucose demand in the body? So remember, when we study our macronutrients, although this is the first topic in our study of macronutrients, we know that apart from carbohydrates, protein and fats basically are alternative energy source. It means that our human body have the ability to actually obtain energy from proteins and fats apart from carbohydrate. So when the carbohydrate intake is inadequate or insufficient to meet the energy demand, the glucose demand in our body, what happened actually? First, body proteins will be broken down to make glucose. Remember, our body needs glucose for energy. The unit of energy in our human body is always glucose. Although protein can be an energy provider, but protein has to be converted to glucose so that our body can use the glucose as the energy unit. So the conversion of protein to glucose is called gluconeogenesis. Basically is gluco means glucose. Neogenesis means to make. So proteins have their own functions in our body, and by actually channeling the proteins in our body, or proteins derived from our diet to actually provide energy or convert it to glucose to provide energy, we are depriving our body from one of the more important functions of the protein, which is to build and repair tissues. So the process of converting proteins to glucose for meeting energy demand can actually disrupt the normal functioning of our body in terms of building and repair tissues, building important enzymes and proteins, etc. in our body. We'll now move on to another topic which is actually quite popular right now. Maybe because Health Promotion Board is actually targeting on the amount of sugar that the general population consume right on a daily basis. So let's talk about sugars. The big thing about sugars, right, in this particular few years is actually it deals with the consumption level. The consumption level has increased over the past 30 years, right? Up by 23% in the past 30 years. Okay, and why? Why do we consume more and more sugar? And this basically it actually deals with the type of food that we eat. Okay, and basically because of modernization, because of food becomes more readily processed, food is more abundant, etc. And basically, also that sugar sweetened beverages are everywhere now. Okay, and people love or like to consume, okay, sugar sweetened beverages. Okay, so soft drinks, even fruit juice becomes a significant source of our daily sugar intake. Now, sugar that basically, okay, there are a few types of sugar, right? Okay, sugars are still sugar chemically, right? Whether is it natural sugars, okay, a lot of people like to call it natural sugars, which is actually sugars that naturally present in food products. Okay, all food products, or most of the food products contains carbohydrate, and carbohydrate itself, I told you before, we talked about it before, that basically is also sugars. There's some sugars in it, simple sugars in it in food as well. So sugar can be found naturally in food, or we call them natural sugar. But there are sugar that are being added to food. Okay, we add we add sugar in our coffee, add sugar in our tea. We get sugar sometimes even in our orange juice, because I think the sweet sensation here is very addictive, and basically is very addictive as well. Addictive, but in the sense that people tend to take things even more sweeter and sweeter things, etc. So sucrose is added to other food. We call them added sugar. So we have natural sugar versus added sugar, right? And even the common ingredients like breakfast cereals, sugars are also added into it. Okay, and not to mention that even the healthy food, right? Food that are considered healthy, like fruits and vegetables, they also contain sugars. Okay, albeit they are natural sugars, right? But sugars are seldom found in animal products. Okay, they may be present, but the amount is relatively very low, except for milk, where the primary sugar, right, is actually lactose, and the lactose in the milk is basically a very important sugar because this is the primary energy source for the youngs, the babies, the toddlers, okay, which are still not able to take semi-solid or solid food to derive their sugar or natural energy from. Now, a lot of people ask, yes, there are natural sugars present in fruits, vegetables, and grains. Okay. Now, why are they more? It's chemically, sugars are sugars. Sucrose is sucrose. Glucose is glucose. But why are they more healthy or healthier than sugars in soda and candy? Now, the answer is very straightforward. Okay. We have to look at what other things are present in this food compared to the soda and the candy, right? Fruits, vegetables, and grains have more other nutrients. Okay, to us, to nutritionists, to dietitians, we have to understand that apart from sugar, we need other things from our diet. And basically, fruits and vegetables and grains provide other things like fibers, like vitamins, like minerals, okay, like phytochemicals. So we are looking at more than just sugar. Okay, if there are other nutrients that we can take together with, per se, the natural sugar, that is definitely better than just taking sugar from candy and soda. Now, this slide basically is derived. This particular table is derived from a textbook. Okay, basically this shows you in general how many teaspoons or grams of sugar that can be present in all these type of commonly consumed food like soft drinks, milkshake, fruit punch, chocolate, etc. And basically it's quite astonished about the amount of added sugar inside them. Okay, so I'm not asking you to actually refrain from them, but we should, if you are concerned with the amount of sugar in your diet, we should limit the amount of added sugar instead of just plain sugar. Now everybody is very concerned about, everybody is so concerned about the sugar intake is because of the health implications, right, that actually associate with sugar. A diet high in added sugar may lead to, your oral issues, dental cavities, increased calorie intake will lead to obesity, right? Alter blood lipid profile that will actually severely deteriorate your heart health. Okay, uncontrolled diabetes. If you are diabetic, or touch wood. Okay, if a person is diabetic, definitely eating over consumption of glucose doesn't help you to control your blood glucose level. And definitely, right, if you're taking a lot of empty calories, I should say, products with added sugar but without any nutrients, right, other nutrients, then basically you are actually, you may run into nutrient deficiency. How do a person reduce the amount of added sugar in diet? Okay, the most important thing is, right, usually a product that have added sugars, okay, that means there's, usually they are processed food or manufactured food. They are not fresh, whole food. So definitely, there is a food label that accompany the food products. Use the food label. Okay, use the food label to know what is the amount of sugar that's added into it. And you should compare the number of sugar grams to the number of carbohydrate grams. If the difference in number is small, then definitely the food is likely to be high in added sugar. So that means most of the carbohydrate is actually added sugar. Okay. Now, importantly is we are not asking you not to take in added sugar. Moderation is the key. Okay, definitely, all the sweet desserts, so nice, right? What is the best way to end a meal is definitely the sweet dessert. So, but the moderation is always the key, right? Moderate the amount of sugar, sweetened beverages you're taking, moderating the amount of sweet confectionaries that you actually take. That will basically goes a long way to limit the amount of added sugar in your diet. Now, this has always been talked about, natural sugar versus added sugar. Yes, choose food that contains natural sugar rather than added sugar. So choose your fruits, choose your vegetables, right? You can actually, instead of taking something that's sweet but without any other nutrients, rather take something that's sweet and there are other nutrients with it. So choose fruits when designing something sweet, or for non-pre-sweetened breakfast cereals. Okay, add fruits to yogurt rather than buying varieties with fruits added. Okay, so basically you can buy the plain yogurt, then you cut fresh fruits and then add into your yogurt, rather than buy the ready-made, yogurt with all the sugar-coated fruit cubes inside. Now, number 4, if you really, have a very, very, very sweet tooth, you can actually replace, sucrose with artificial sweeteners and sugar alcohols. Next, we'll go through what are the carbohydrates intake recommendations. Okay, if you talk to a nutritionist, right, for the healthy person, we basically hopes that you can derive, up to, your daily energy intake, your daily energy intake, 45 to 65% of your daily energy intake should be derived from your carbohydrates. Okay, right? 45 to 65%. That being said, it means that carbohydrates should be the major source of your energy. Okay, now we can talk about the fats next time, but actually this particular slide also talk about fats being 20 to 35%, protein 10 to 35%. But the major source of daily energy should derive from your carbohydrate. This slide basically helps you to work out, how much carbohydrate should be taking based on your estimated energy requirement. For example, Jane, this person's estimated energy requirement is 1,800 kilocalories per day. So if you can, based on our guideline of, that Jane should derive 45 to 65% of this 1,800 kilocal, right, from carbohydrates. Basically, you can work out that, hey, Jane will require to take in between 202.5 and 292.5 grams of carbohydrates in a day. I think the calculation is quite straightforward. I think you can as easily work out on your own. I won't go through the calculations. Okay, I just mentioned that, what is the amount of carbohydrate intake recommendation based on energy expenditure. Okay, based on the facts that, carbohydrate is the major source of energy, okay, in our body. But what about this particular type of carbohydrate that is actually a very important nutrient? It serves a very important function in the body, but it's not metabolized by our body, and therefore we cannot derive energy from it. Yes, I'm talking about the dietary fiber. Now, we definitely need dietary fiber because, a lot of clinical studies says that dietary fibers basically not just help to maintain and promote our intestinal and gut health, but it does have other, health benefits. Okay, we'll talk about it, if we have a chance in next few modules. Okay, not in this module. Now, for a nutritionist and a dietitian, how much do you recommend? How much dietary fibers would you recommend for a healthy person? Okay, technically, a healthy person should consume 14 grams of dietary fibers. Okay, we have no guideline of how much of the dietary fibers should be soluble type or the insoluble type. But all in all, a healthy person should eat 14 grams of dietary fibers per 1,000 kilocal. Here say just now Jane is 1,008 kilocal per day, right? So it's 14 grams times 1.8. Now that is the amount of dietary fibers they should take. Like for me, for example, I think my daily energy intake is around 2,000 kilocal. So I should be taking around 28 grams because per 1,000 kilocal is 14 grams. 2,000 kilocal should be 14 times 2. I should be taking in 28 grams of dietary fibers. I don't think, even if I did a preliminary calculations, even if I take, the Health Promotion Board recommended 2 servings of fruits and 2 servings of vegetables per day, I think the maximum amount of dietary fibers I take in one day is less than basically 15 grams. Okay, now maybe we should discuss about this in upcoming modules, okay, but not in this module. But what do the nutritionists recommend about added sugars? Now, nutritionists and like health professionals are usually very, very, very against added sugar, right? Now, but there's a guideline. Not that you totally cannot, take in any added sugar. Then life will be quite sad, miserable. But the recommendation for added sugar is such. Added sugar should contribute to no more than 10% of the dietary energy. So, for example, our Jane is 1,800 kilocalories. So basically 10% of 1,800 kilocalories is around 180 kilocalories. 180 kilocalories divided by 4. That basically works out how many grams of added sugar that Jane can basically should take in a day. Okay, so basically around that, then when we do this calculation, we basically translate to around 40 to 55 grams of added sugar per day. That is just basically 8 to 11 teaspoons daily. Right? So basically added sugar includes our intake of beverages, sugar-sweetened beverages, desserts, cakes, candy, etc. Okay, since we're on the topic of sugars, so what are different alternatives to sugars? Why do we need to talk about, sweeteners alternative to just sugar? We need to know that people love sweetness. Okay, the taste of sweetness is actually a very desirable taste, in fact. Okay, so what are the advantages of using sweeteners? Okay, now when on this slide I'll talk about advantages of artificial sweeteners, right? Okay, but we can actually generalize it as I don't care whether is it natural sweeteners, because nowadays there are natural sweeteners. Okay, not only the man-made one, there are sweeteners alternative to sugar, right, that is found in nature. So what are the advantages of using sweeteners? Okay, now basically first thing is, in terms of energy content, sweeteners are usually low or even have zero energy content. It provides virtually no energy at all because our bodies cannot metabolize it. We can taste the sweetness of these sweeteners on our tongue, but once it gets into our system, into digestive tract, etc., most of it are not metabolized. Okay, most of it are not used. That's why they are not a form. It's not providing any energy. Now, because it's not metabolized by the body, it's also not metabolized by bacteria, and therefore the bacteria on our teeth cannot use this as an energy providing source, and therefore it actually doesn't lead to tooth decay. So they have less concerns in tooth decay. Definitely, you look at diabetic, those people with diabetes, right? They can't metabolize glucose very well. The blood glucose control is not very well. So, right, by taking the glucose out of the equation, by having this sweetener that cannot be metabolized, it's a good substitute of normal sugar for these diabetic people who cannot resist the sweet sensation. And also, most of these sweeteners have very intense sweetness. Intense sweetness means, they provide high degree of sweetness compared to just the normal ordinary sugar. Like for example, the saccharin basically is 300 times sweeter than the sucrose. The aspartame is actually 200 times sweeter. The sucrose is actually 600 times sweeter. Okay, and therefore, because they are so much sweeter than our normal ordinary sugar, we do not need to use a lot. We just need very little. So remember when I don't know whether nowadays the cafeterias, the cafe do provide artificial sweeteners, okay, on the table, okay. So basically, you can see that the equal sugar, the packet is so comparatively small, and the amount that you added into your coffee and tea is so comparatively so little amount those ordinary sugars. Okay, and basically all the advantages of sweetener is whenever there's sugar shortage, this sweetener can be used to replace the sugar in order to provide the food or to enhance the sweetness of food products. While we can talk about all the advantages of sweeteners, be it natural and artificials, controversies do arise. Okay, there are good in life. There's good thing. There are also bad things. Okay, right? Just like the normal sugar. Right? There are also two sides of the coins. Let's talk about controversies involving aspartame. It contains two amino acids, aspartic acids and phenolic. It's actually amino acids. It's actually something like protein or dipeptide. Now, the problem is because it contains these two amino acids, it's not suitable for patients that suffer from the phenylketonuria, which is they are unable to dispose these amino acids from their system, and that basically leads to undesirable effect like brain damage, etc. Okay, some of these people will exhibit vague or not dangerous symptoms. Some will actually, I don't know, maybe it's quite dangerous for them. Nevertheless, FDA, Food and Drug Administration of the United States of America, does approve it for safe use. Next, saccharin. Right, sweet and low is actually a saccharin. They are taken off from the market. Okay, basically some time ago. Okay, basically they say the high dose cause cancer in lab animals, and therefore they're taken off the market. Right. However, that was in the 1980s or 1990s. I forgot about the history of actually the saccharin. Okay, now anyway, this module is not talking about history. But however, it is removed from the list of suspected cancer-causing substances in year 2000, and the warning labels are no longer required. So now, saccharin is approved for use in more than 100 over countries, including Singapore. Next, we talk about sucrose, which is one of the more recently has been quite popular. Sucrose is somehow very similar to the sugar in terms of the chemical structure, and basically it has a very close to sugar-like taste. Okay, but it's not natural. It's totally artificial. Okay, the digestion and absorptions of sucrose is still not it's not very well studied at this meantime, right? And most of the study on their digestion and absorption is basically done on animal over a short period of time. So nowadays, this sucralose is sold under a trade name called Spenda, has been actually approved for use. So this is one of the newer, I would say newer artificial sweeteners. Like I said previously, sweeteners alternative to the normal ordinary sugars can be found in the nature. Okay, so sometimes some people call it natural sweeteners. Those sweeteners that I actually talk about, just for the past few slides, they are artificial sweeteners that are man-made. Okay, right? Okay, and usually, they have a lot of controversy. But what about natural sweeteners? Now, natural sweeteners come into the market, I think, for less than a decade, right? And usually we have only, at this moment, I can only think of two natural sweeteners. Okay, the first one, I don't know whether you heard of it or not, stevia. Now, stevia basically comes from a stevia leaf, okay, a plant, okay, the leaf of a plant, right? And basically, this leaf have this particular molecule called the stevia, okay, right? And basically, this is when they extract this stevia out, this stevia is very sweet, okay, we use this as alternative sweeteners in food and beverages. Okay, monk fruit, I don't know whether, the Chinese call it the 罗汉果, I think the monk fruit has been, I basically grew up in a Chinese family. Basically, my mother usually used 罗汉果, the monk fruit, to cook herbal tea for me since young. Now, basically, monk fruit is how Chinese traditionists, okay, or TCM, or sweeten the herbal mixture, right? So monk fruit has long been used by the people, okay, of China. While stevia leaves is actually originate from South America. So basically, tradition people in South America is just using stevia, right, leaf to sweeten whatever food product and beverages. Both, whether it is stevia or monk fruit, is granted by FDA as generally recognized as safe, and basically they can be used as additive in both food and. And last, I want to mention alcohol sugar. Okay, so alcohol sugar is actually another type of alternative sweeteners. I think you'll find this alcohol sugar in abundance in all those like sweets, herbal sweets, where you actually by the end of your grocery shopping, while you're queuing out at your cashier counter, usually on the stands there they will put down a lot of sweets, etc. And one of those sweets, all these sweets have this tooth logo, and then there's an umbrella above the tooth telling you that basically it uses sugar, alcohol to sweeten the candy, and therefore it's actually it's not harmful to your teeth, etc. So again, alcohol sugar, it cannot be metabolized by the bacteria in your teeth, and therefore it doesn't cause any tooth decay. Okay, but although it's called alcohol sugar, basically it's called because of this chemical structure. It's neither a sugar nor an alcohol. Okay, they are mostly polyenols. That means they have multiple alcohol groups attached to it. Okay, examples of alcohol sugar include salbutamol, xylitol, and mannitol. Okay, and basically they are often found in sugar-free products such as chewing gum, candies, bread milk, etc. Now, the one thing about sugar alcohol is a natural sugar. It's a natural sweetener. Occurs naturally in plants, especially in fruits, right? And definitely, it doesn't produce. It's not 0 calorie for alcohol sugar. It does have some calories, but half the calorie of sugar, around 2 to 3 kilocalories per gram. Now I talk about very how do I say it? A clinical term, okay, glycemic response. Okay, why I call it a clinical term is because this is how we measured, this is how we study how actually sugar, right, is regulated in our body. How does blood sugar concentration varies in our body? So a glycemic response. How does our intake of sugar causes changes in our blood sugar concentration? For a glycemic response in our human body, I would say that, like remember I said that a glycemic response is a study of how carbohydrates affects the blood glucose concentration in our body. Okay, over time. So it's a response. It's always over time. Now, in order to study, right, in terms of nutrition, right, we actually look at both aspects. We look at the carbohydrate quantity. That means the amount of carbohydrate that we take versus the quality of the carbohydrates that we take. Okay, and how the quantity and the quality affects or influence glycemic response. Okay, in fact, I will in a next few slides, I will tell you that both quantity and quality are important, not just one, both. So to better understand, glycemic response, there are two terms that we need to actually understand. First one, glycemic index or GI. Now, the definition is quite short. They said glycemic index is the ratio of the blood glucose response of a given food compared with the standard, typically just pure glucose or white bread. So in a supermarket, basically, sometimes we saw that, this is a food and the GI or the glycemic index have been tested for this food, and there's a number. Okay, the number will tell you, is this a low GI, mid GI, or high GI food? Okay, so we use GI to gauge the glycemic response. That means if you take this food, if you take 1 gram, how many grams of blood glucose increase will you see if you take 1 gram of this food? Okay, so this is GI. What about the next one? GL or glycemic load. Glycemic load is not just GI. Okay, it's more than GI. Glycemic load is GI and the amount of carbohydrate consumed. So it doesn't just look at quality, it also looks at quantity as well. So GI looks at the quality of the carbohydrate. 1 gram of white bread versus 1 gram of rice. Which ones have a higher GI? The one with the higher GI will cause a higher glycemic response. That means your blood glucose will change more, higher, compared to the one with lower GI. So this deals with the carbohydrates quality. But when we talk about GL, we also look into not just the glycemic index, but we also look at how much of that carbohydrate are you taking into the body, right? Okay, so we call it glycemic load. So if you look at the balance again, the quality is actually defined by the glycemic index, while the quantity and the quality itself works together basically defines the glycemic load. Like I said before, the GI or the glycemic index is actually a measurement of the carbohydrate quality. As the name implies, glycemic index is an index. It's an index. It's just a number. And this number, it helps us to classify foods according to the potential for raising the blood glucose. So a higher GI means it has a higher potential of raising the blood glucose level. So technically, GI measures how much blood sugar increases in 2 or 3 hours after eating. The 2 or 3 hours is the time allowed for the food to be digested and the glucose to be absorbed into our bloodstream. The lower the GI, the better the impact on it. Means the lower the GI, the lower the potential of increasing the blood glucose, and then the better the impact on our glucose level, because you want the glucose level to increase slowly and stay increased longer rather than to have a sharp increase over a short period of time. So this graph basically shows you, the difference, in terms of a high GI and versus a low GI food. Okay, so a high GI food is a food that has a glycemic index 70 and above. What does it do? Basically, when you actually plot the blood glucose level over time, a high GI food will actually cause a rapid rise in blood sugar concentration. Okay, and after a sharp rise, it's actually followed by a sharp fall in the blood glucose. So, but for low GI food, 55 or below, okay, even though it contains the same amount of carbohydrate, the increase in the blood sugar is considered or slower. So the increase is slow and low, followed by a gradual fall in the blood sugar. I can see from the green graph over there. That's the difference between a high GI and a low GI food. So what happens when you partake a high GI food? Okay, digestion will be faster, a quick release of blood glucose, raise blood glucose level rapidly, attain high blood glucose level. For low GI food, slowly digested, slow release of food of the glucose into your blood, then gradual rise in the blood glucose level, and basically is good at maintaining an ideal blood glucose level. This is a slide listing some of the low GI, medium GI, and high GI food. Okay, low GI is food is typically classified as those with a GI or glycemic index less than 55. Right? Some examples are the natural fruits, grains, and milk. The medium GI is basically having a food will have a glycemic index between 56 and 69. Okay, they include some fruits as well, some very sweet fruits and some desserts as well. And high GI basically are highly processed food that we can see. Watermelon is actually considered high GI food, okay, comparatively. So we'll be talking about high GI, low GI, high GI versus low GI. So what are the benefits of having food or taking food with low GI? One thing we can say about is it will have better glucose control, especially for people who have problem controlling the blood glucose level, like those people with diabetic. Definitely, if you can control your blood sugar very well, it can improve how your body manages the blood lipids or the blood fats. And by controlling both the glucose level and the blood lipids level, it basically reduces the risk of developing heart diseases, okay, and definitely weight management. Now, the disadvantages of having low GI food, okay, basically the structure of low GI food is actually influenced by a lot of food science, food starch structure, fiber content, food processing, physical structure and temperature, amount of protein and fats, okay. So basically, it's very difficult to gauge, okay, and also GI, remember, is just the quality of the carbohydrate. Okay, we have another bearings, the quantity. Okay, we'll look at the glycemic loading in the next few slides. Like I mentioned earlier, glycemic loading is take into considerations of both the carbohydrate as well, the quality of the carbohydrate as well as the quantity of the carbohydrates. So glycemic loading is the amount of carbohydrate in a serving of food multiplied by the glycemic index of that carbohydrate. So that's why I'm saying it has both the quality and the quantity. And the result is then divided by 100. So that is the formula of the GL. Okay, so GI multiplied by the intake divided by 100. Okay, so classification wise, right, we have it's from 0 to 20, the range. Right, if it's less than a GL index, a GL of 10 is considered a low GL food. If it's between 11 to 19, it's a medium GL food. And if the value is greater than 20, it is considered, the range is actually more than 20, right? It cannot be 1 to 20. If it's higher than 20, then it's actually it's a high GL food. Food with high GL will lead to high secretion of insulin. Right, okay, and definitely chronically high insulin outputs will lead to high blood triglyceride, which is the blood fats, increased fat deposition in the digestive tissue, that means you grow fats, increased fat synthesis in the liver, and more rapid return of hunger after a meal. Okay. This is a table listing the GL of a certain food. Okay, I think in your free time you can actually take a look at it. There are multiple sources of GI and GL literature, right, in the Health Promotion Board database or FDA database, right? If you are not sure about the GI level or GL level, GI or GL level of certain food, you can actually go and find out from this database. Now, the last section of this particular lecture is on carbohydrate. I will deal with concerns related to carbohydrate intakes. I understand that a lot of people think that dietary fibers is actually a very, very, very important component, a very, very useful carbohydrates to incorporate in our body or to take in our diet. However, and that's why there is this very high fiber diets. Okay, now we understand that intake of dietary fibers have positive health benefits. Adequate intake, okay, sufficient health intake. Too low, no good. What about too high? Especially if we engage in a very high fiber diets. Now, the first thing that we know that if you engage in a very high fiber diets, you will have issues with your bowel, right? This excess amount of dietary fibers, and if coupled with insufficient fluid, that means you must make sure if you don't take enough water, okay, right? It will cause us very hard, dry stool that are painful to eliminate. So constipation, and it may because of this hard, dry stool, it may cause hemorrhoids, rectal bleeding, right? Because of the difficulty in trying to excrete out or push out the hard, dry stools. In severe case, it may cause internal or intestinal obstruction. Okay, and this may actually require surgery to actually rectify this problem. And high fibers, okay, fibers have a very, very negative thing, annotation to it, is because they have the ability chemically to bind certain ions. Okay, ions are basically minerals, or minerals are basically ions. So if you have too much fibers in your diet, these fibers will somehow causes a decrease in absorptions of these minerals, and we will run into a probability of minerals, the risk of mineral deficiencies. So to summarize, if we have too much fiber intake or excessive fiber intake, too much pulp filled too soon, we will have experienced abdominal discomfort. The binding of minerals in our gut will actually minimize, or interfere with the mineral absorption. Therefore, we actually may lead to mineral deficiency. All right. If you are taking any medication for your certain medical condition, these fibers will actually bind to this medication. Right. This medication is not absorbed into your body, and because of if coupled with inadequate water intake, it may cause constipations. Next, let's talk about the high sugar diet. I don't know which one nowadays will actually engage in the high sugar diet. Nevertheless, this is one of the quite, I would say, popular diet. Now, if we are engaged in a high sugar diet, especially those with very, very sweet teeth and those who love dessert, all right, increase the risk of weight gain and obesity. This high sugar diet can be quite commonly seen in children, because I don't know. I try to regulate the amount of sugar or added sugar intake in my children. Okay, because of the because I think sugars are basically very empty calories. It doesn't offer anything. But I don't restrict that. I will moderate rather than restrict. Okay, increase the risk of weight gain and obesity. A high sugar diet. Now we know that obesity is a major risk factor for type 2 diabetes. Okay, right? And high intake of energy and sugar, especially fructose, are associated with an increased risk of CVD, or cardiovascular risk, or cardiovascular disease risk, and raising the blood triglyceride and decrease the HDL cholesterol. Okay, the HDL is the high density lipoprotein, okay, which is actually the good cholesterol in our blood. So I mentioned that lactose is actually the primary sugar or the major sugar in our milk. So basically, we heard this term before called lactose intolerance. Okay, now lactose intolerance arises due to the reduced amount of the enzyme lactase produced in our small intestine. Okay, what happens is this lactase is an enzyme that breaks down lactose, okay, right, into a simpler sugar. So the primary causes is basically the insufficiency of lactase in our small intestine. Okay, or the secondary causes is maybe because there's damages of the cells in the small intestine, which leads to a reduced lactase production. No matter what, lactose intolerance is because of insufficient amount of lactase. Now, what are the symptoms of lactose intolerance? Bloating, abdominal discomfort, diarrhea, and flatulence. I myself have a bit of lactose intolerance. I think most of us have a bit of lactose intolerance, unless you'll be constantly drinking milk daily, and therefore your body have maintained the amount of lactase production in your digestive tract. Okay, for most of us, or a majority of us, who actually wean from milk, at a tender young age of maybe 5, 6, we stop drinking milk. We derive our energy from other food sources instead relying on milk or primarily on milk. We will basically have less. Our body will start to reduce the amount of lactase formed in our small intestine, and therefore, whenever we start taking milk again, suddenly, be it in your coffee. Right nowadays, owing to the rise of Starbucks coffee, cafe coffee, and this coffee contains a significant amount of milk if you choose all the latte, flat white, etc. And then we will feel that kind of discomfort in our in our tummy, flatulence, bloating, abdominal discomfort. We actually live with lactose intolerance. Okay, we live with it by changing our diet, omitting all our milk products that lead to all this that can lead to this nutrient deficiency. And then what can we do is we can not, if we think that milk is very important to us, we can actually slowly increase the intake of milk gradually. Okay, consume with other foods. That means we take milk with other foods than milk, so we don't just take milk. Okay, spread the intake throughout the day and slowly let our body get used to it, such that it start producing more and more lactase. We have if you really your lactose intolerance is really that bad, okay, you can actually they have lactose free diet, okay, right? And so because lactose is not only present in milk, they are found in bread, cereal, salad dressing, and medication as well, a bit in a smaller amount. Last, I was talk about another incident, another special case, glucose intolerance. Okay, now just now we talked about lactose intolerance. What happens if you have glucose intolerance? We need to have glucose in the body because they are the energy unit in our body. Okay, now the question is, we have to keep blood glucose level within a normal range. We call it homeostasis, right? Why? Why do we need to keep that with a normal range? Because high blood glucose will lead to health issues. Low blood glucose levels will also lead to abnormal physiological type of conditions. So we need to actually keep the blood glucose in the normal range. Okay, the word hyperglycemia means high blood glucose level. Hypoglycemia means low blood sugar level. This brings us to the end of the lectures. In conclusion, okay, let me summarize everything. Carbohydrate is the most important energy using macronutrients. We know that protein and lipids also use energy, but carbohydrates, right, its main sole functions in our diet is actually to provide majority of the energy. Okay, it's the main energy source for body function activities. Important to incorporate carbohydrate in our regular diet. Okay, so by right is between 45 to 65%. Fibers, okay, is also part of carbohydrate. Although fibers is not energy using, but is an essential bulking agent and exerts beneficial effects to health. And lastly, about sugar. Sugar is neither bad or good. Okay, it is actually something that should be consumed sensibly. That means we need to, you need to make sense of how much sugar we take every day.